can't remember exactly which classes. It would be really weird if I didn't show you this, but it's possible. Have I shown you the sheet that shows homework's completed and average grade in the class? I did? Or you maybe in another class with me? All right. Well, shit. You guys would have been the greatest ones to show that to. So I'm going to bring this next time. I just didn't have enough time today to get it put together. Stay with me now. What you would expect to happen if I had number of homeworks done, not just what you would expect, but what every time happens, which is like groundbreaking. The number of homeworks done, right, this is the number of homeworks, and your current average, not including homework, because they don't want to put that grade in and have it create what's called a correlation, so it's a relationship between two variables. So what do you think the trend should be? As the number of homeworks done goes up, what should happen to the grade probably? It goes up. Yeah, but it's always nice to actually see it actually happen. So we'll have these things, there'll always be somebody like right there, and there'll always be somebody, at least one person there. What's true about this person here? True, but what's true about it? What's physically true? They have not done much homework at all, but their grade is way up there. And sometimes, believe it or not, the last day somebody comes up to me and says, I didn't know I had to turn the homework in. Holy shit. Am I living in a show? Yes, you have to. So sometimes that's explained by people doing the homework, they just don't turn it in. Or they've taken statistics before, so they actually didn't do any homework, but they know most of it already. You guys with me? What about this person? This doesn't happen much to me anymore now in statistics because I don't do online homework. But every class where I do online homework, there's a little cluster down here of all the online homework people doing their homework. Now, I'm not saying everybody who does online homework does it. Some actually do it. I have a few sprinkled in here that are actually doing the work. But there's kind of good evidence that it's bullshit. Sorry to be very blunt. Has anybody ever done online homework in class? So some people use it correctly, and some people don't. Same thing with out of the textbook, to be honest. But if I kind of ignore these outliers, I could draw a line that sort of averages where the points are. Does that make some sense? Now, stay with me. So this is the line. I love this idea. It's a visual average. And there's a whole lot of computation behind it. What it does is it's the line that minimizes the square distance away from the points to the line. It's called the line of best fit. It best fits the data. This is semi-making some sense. So I have a bunch of data points just spread out. I can draw a line that graphically averages the location of all those points. When would I trust this line to make a prediction about the data? Like, what if I did this much homework? Should I make that grade? I mean, when am I going to trust the line more is when the points are all closer to the line. Then I'd say that the relationship is stronger. So let's get some, let me give you some visuals. This is it's got a couple examples. They are not examples of any experiments that you should perform. Let me just say that at the beginning. Walls. We're just going to do straight lines in here, but I will point out I use a calculator quite a bit in this section. So I will point out how I can calculate quadratic. So I'm not saying you should try this, but I'm sure some of us have lived this, possibly. Not exactly like this, but pretty close. So if an entire class went on drinking the night before, that's a very good idea. Nice bonding of the class, right? A test, and there's 7 a.m. class the next day, so they're out drinking until 1 in the morning, or whatever. Or they start, depending on how old you are. You start drinking at 1 in the morning. We could survey them the night before to see how many drinks they had, and then see the next day what grade they made on the test. So here, which one of these situations? They both show what kind of trend. And I'm not saying this is what would happen. These are just two possibilities. So what kind of trend do they show? So as I drank more beers,
Grades went down.
grades went down. The general trend. Which one of them is a stronger relationship between the two variables, beers and grade?
The relationship on the right.
So the stronger relationship would obviously be that one. Please, is that cool? Why is this one stronger? Because all the points line up better. So what's it mean for two variables to be related? It means as one changes, so does the other one, correspondingly in some manner. So Jacob asked a question a minute ago about, are we going to look at curved correlation? No, we're going to focus on linear, but I will bring up the idea of curved correlation. For example, energy use through the year might look like this. Right, and actually kind of goes like this. Summer, and then spring, and fall, and then winter. I know in San Diego it's not quite those all seasons, but winter never comes. Which one of these, so that one is stronger, because they all line up better. Which one is more realistic, of course? This one's more realistic. Who is this person? You're like, it's Jim. No, I mean, they didn't drink much, but they didn't make it. All right, so if they don't know shit, it doesn't matter how little they drink, they're not going to be able to do well on the test. And who's this person?
They're really good at drunk stats.
Yeah, exactly. Have you ever played pool with people like my friend Scott? If he got drunk, he'd get better and better at pool. Me, I just got progressively worse. So there's a sweet spot I had to try to hit. Anyway, so this person drank a lot, they can hold their liquor, and they knew their shit, right? So they're way up there. So those are outliers, like somebody said earlier. If I kind of ignore those two, even with those two, you can see a downward trend. If I had a number, so sort of like, I love this thing about this. Standard deviation tells you what? Oh shit. What does standard deviation tell you about a set of data? Distance away from the center. I'll say it even more generally, right? Standard deviation is an average distance from the center. In these problems, the center is going to be the line of best fit. It's going to be the graphical average, the line that goes through the data points the best. If I could calculate a number that captures how far away from that line the points get, that would be just like standard deviation, just in 2 dimensions. Let me say this again. So, this number that I calculate would have to be very different for these two. I would think for this one it would be closer to 0. And for this one, it'd be closer to some kind of maximum number, because this is very well lined up. Just think about that. So this number is going to capture how strong the relationship is. And what measures visually how strong the relationship is? How well the points line up. So that one's stronger and this one's weaker. So I should see definite differences between these values. I almost said what it is. It's going to be given the letter R. Okay. Which is why I try to get you guys to write sigma instead of R earlier this semester, because R has a purpose. So let's do something that's a little less controversial as far as suggestions of what to test out. Here's another situation about something that could affect grades. Hours studied versus grades. So you would expect, so obviously this one's the stronger one because a line really, the points follow that line pretty well. This one's weaker one, but that one's more realistic. Again, this is the person that maybe took stats before or whatever. They just get it from the class. You can hate those people as much as you want to. You do what you got to do. And this is the person, of course, I don't think they know what studying means or something. Right? This happens a lot. I studied for 8 hours. What'd you do? This crazy thing. Well, that's not going to help you. Okay. Maybe. You guys getting the basic idea here? All right. Now, what's the problem with this? Can anybody notice a problem with these two? They both talk about what? They both talk about grades, but they attack it from two different angles. How many things affect the grades of a student in the class? So many things, right? So the downfall, kind of like the weakness of this analysis, is that I can only compare two things at a time. There's another statistical analysis called an ANOVA. I'm not sure we're going to have much time at all to talk about them, but it's able to do multiple categories of things. All right, you guys look so excited.
Standard deviation in 3 dimensions.
Yeah, you can have a 3-dimensional correlation, sure. Okay. Well, we're not going to be able to do any of that. That would be like a stats 3 class maybe, or 2. All right. So again, now what's the other fundamental difference between, so these two are both talking about grades. What's the fundamental difference between these two? Obviously, as this goes up, this one goes down, but as this goes up, this one goes up. So this is a negative correlation, this is a positive correlation. Okay, so that's directly related to slope. You gotta love that shit. Okay. So it'd be great if we could figure out some number that would tell us the strength of a correlation, and that's the R number I was talking about earlier. Correlation coefficient, Pearson product. Of course, my first stats teacher's name was Pearson. Thankfully, he wasn't trying to take credit for this in any way. He just happened to be named Pearson. So the way that the formula is put together, the way that we've standardized these scores, a -1 coefficient, a -1 R value means perfect negative correlation. Perfect. What do you think perfect would mean? Are either of these perfect correlations? Do you think any of these are perfect? What do you think perfect would mean? Perfectly straight line. So if I draw a line, every data point would fall on it. That's perfect correlation. That's lockstep correlation. Nothing really is perfect correlation unless it's something kind of made up. Okay. And positive one means perfect positive correlation. So most things are going to have somewhere between -1 and 1. 0 means no linear correlation. There's no straight line that shows which way this data is going. Okay, so the closer to 0 it is, the weaker it is. Closer to 1 or -1, the stronger it is. I like it. And again, I love the idea that it's kind of like a 2-dimensional standard deviation, this R value. Okay, now what really sucks is I shouldn't bring any calculator. So, what I think I want to do, I want to get you guys started on this one. I'll go grab the calculators. How many people need to borrow a calculator? How many? Anybody need to borrow it? 1, 2, just a couple of you guys. All right. Get you started on this. A little rundown memory lane for algebra. draw anything on this yet. Let me show you the idea.
I already drew my name.
Some of you guys, this is sort of a bad nightmare, but too bad. Hopefully some of you remember your line stuff in algebra. This is why I take algebra for statistics. So here's the idea. You almost will definitely have to draw at least a couple lines. So I'll use a pencil. Look at that, I'm using a pencil, that's nice. So I'm going to try to draw, even a straight edge would be great. I'm going to try to estimate a line. I'm going to look at it. Well, that's not a great line, Jeff. Let's try it again. Choose one particular. Let me just draw one just to show you. Watch me draw a perfect one. All right. Can anybody tell me, that looks pretty good? Shit. I mean, why does that look good? It looks okay. Right? That line looks okay. What is it doing that makes it look okay? I know we just got into this, but what's your gut tell you? Why would I think that that line is decent for a best fit line?
Next to everything.
Yeah, it's kind of close to every point. The one thing that's a little bit off about it is there's more points on this side than the other side, but it's kind of like equidistant from every point. That's what you're going for. So every single person in here might have a slightly different line. You might have to draw it once, go, oh shit, it should be like down a little or over a little. Right, so draw the first one light. I didn't mean to make mine fun. This is not bad. I would actually use this sucker. The next thing you need to do is to pick a couple points that your line goes through. Now my line happens to go through that point right there. That's the point 7, 15. And let's see if it goes through another point. Let's see. Does it look like it goes through another point? Well, maybe right here, maybe. Let's see if I can find a better one. Yeah, right there. Look, it goes right there. That would be the point 10, 12. I got to find 2 points that my line goes. Because, of course, how do you get the equation of a line? You need to have at least 2 points. Does this sound familiar? So you're going to draw your line. You might have to draw it a couple times. You're going to pick a couple points, and you're going to find the equation of your line. You got people near you. If you need some help remembering how to do that, I gave you the formula. Please do God tell me that looks familiar. And in fact, that is coming from the general definition of slope between 2 points. So do it. I'll be right back with the calculator.